Hi folks, so in this video what we're going to be doing is another type of transformation geometry that you would learn in your junior cycle program. In a previous video we already covered a translation. Now what we're moving on to in this one is axial symmetry. Okay, it's generally the second one that teachers might cover after a translation. Okay, as you can see here, I've kind of got two little setups here, one on the left hand side and one on the right hand side. I'm going to complete this one first and then I'll do a little quick explanation on this one and where a small difference can occur on occasion. So to start off, this is called axial symmetry. So it has a lot to do with what it says in the name, axial, meaning we're going to be using an axis. So often in a question, you're going to be told, you're going to be given an object. Once again, we're going to use the arrow here to explain it. The arrow is made with a grid of a grid that is made up of 10 by 10 millimeter squares, and it is 50 long and 40 millimeters high. So for anyone who wants to replicate this at home to practice, they can. And this axis line here, AB, is done at any angle. I just guessed the angle beforehand. So what we want to do is, when we're doing axial symmetry, what we're trying to do is we're taking the image here and we're trying to flip it over here and get the mirror image of it on the opposite side. So all the points on the object, which there are 1, 2, 3, 4, 5, 6, 7 points altogether, I want to get the mirror image of all those 7 points on the opposite side. Okay, that's essentially what we're doing. So to get the mirror image, we have to project perpendicular to the axis line that we are given. The axis line I've been given is the line AB. Okay, so there's a couple of ways you can do this. The way I usually like to do it is, I get my 45-degree set square like this. Okay, I'll zoom out there a little bit so you can see it a little bit better. I get my 45-degree set square like this, and I put it on the axis line that I want to go perpendicular to. Okay, I get my other set square and I put it underneath it. And then all I do to go perpendicular is, it's twisted 45 degrees this way. So if I twist it 45 degrees the other way, I'm now gone perpendicular. So at every one of those points, what I want to do is, I want to project up perpendicular to the axis. So there's 1, 2, depending on how the distance away from the line, you can kind of roughly estimate how far you have to go out on the opposite side. 3. Bring it back a little bit. So you can see here I'm just doing sliding set squares. This one's probably the closest, so bring that one to about there. Got 2 more to do. 4 and 5. Sorry, should say 7. So there's all the lines projected up perpendicular to the axis line. Okay, now what we're going to do is we're going to use our compass. Okay, so using the compass, what I'm now going to do is I'm going to take the distance from the axis to every one of those points. So you can see there that distance there. I'm now going to mark that out on the opposite side. So there's that point. Now you could give all these points actually labels if you wanted. You could call it, let's say, numbers 1, 2, 3, 4 and all so on. Or you could give it letters A, B, C and so on. Okay, so I've done the first one. Now I'm going to do the next one. So the distance from the axis to the point. There we go. Mark it out to the opposite side. If you need to extend your line, you can see here I'm a little bit short, so I'll extend that after. Likewise with the next one. Just long enough on that one. And there's the next one. And you keep repeating the process. And that one you can see here, need to extend out a good bit further. And then finally this one, need to extend that one a little bit further as well. Okay, so wherever I need to extend, just get that done. At this point I'll just go back to my sliding set squares. And there we go. Okay. Extend that a little bit further. There we go. Right, so there's all my points. Now what I want to do is I want to connect them up. So I can see that this one will connect to this one. Okay, so make sure, this is why labeling is actually often helpful. Because you can see here I've got a series of points. I just want to make sure that I've connected the right ones. Now, I know this one here, I'm creating the triangle here. This one connects all the way to this one. Do it ever so lightly. And I only heavy as far as here, and you can see it's after going through my other points, so my accuracy is good. Now at this point, what I'm going to do is I'm going to line up these two. And I will always just check that I'm still parallel. I'm happy with that. Yep. So there's that one there. That one. And finally, last one there. And there we go. Okay, so the method is, okay, just follow the steps. You want to go perpendicular to the axis from every one of the points here. So as you had seen there previously, I set it up on my axis, and then having set it up on my axis, put my other set square underneath, and then rotated it about to go perpendicular to it. Then I take the distance from the axis, and I set out that distance on the opposite side, and it will help me determine every point on the object. Very important though that you don't get confused on the points. Okay, so that's the method of how we do it. The odd time here, sometimes they'll say, get an axial symmetry of the image here, so an arrow again, from A to A1. So in this case, you can see we're given A, like we maybe would have had here, and we're given A1 over here, but we are not given the axis line. So in that case, all you would do is this. You would connect A to A1, like that, and then what you have to do is you have to get the middle of that line from A to A1. So to get the middle of any line, we don't know the distance, I'm going to bisect that line. Pick a distance greater than halfway, swing an arc, and an arc, keep your compass distance the same. And all I'm going to do now is connect these 2 points. And what I've created there now is my axis, okay? And as you can see here now, we're at the same stage as we were back over here. At this point then, all I would have to do then is do sliding set squares. I'm not going to complete the whole problem, but just to give you the idea, if I wanted to find all of these points then again, I would simply continue on with my sliding set squares, okay? Going perpendicular to the axis. The only difference with this one was I had to determine the axis, okay? So that's the axial symmetry there, guys. That is the second transformation geometry. Hope you found that helpful.